Hi everyone. In this section, we're going to start working on more general rules, so not specific shortcuts for specific functions, but rules that apply to combining more than one function. In particular, the product and quotient rules are what we want. So the idea is if you have two functions that you know how to take the derivative of, and then you multiply them together, what is the derivative of the product? And ideally, we would love it if the derivative of the product was the product of the derivatives. So we would, I think a lot of people hope to see that the derivative of f times g is f prime times g prime, but it's a little more complicated. So this is the preview activity, this first page, if you want to pause and run through it. Sorry for the wobbles. And then check back in and make sure you got it. This will just get you on board with what we're trying to do. Okay, so we've got two functions and they're fairly straightforward functions. So we have f of t is equal to 2t squared and g of t is equal to t cubed plus 4t. Ooh, hold on, I see I need to turn autofocus off. Get it focused. Maybe. Okay, sorry. So first thing we're supposed to do is find the derivative of each of these separately. So the derivative of f of t is going to be a constant multiple 2 will hang out in front. The 2 will drop down with the power rule and we'll get 4t to the first. And then the derivative of g to the t, we have a sum. So first we'll look at the t cubed. Its derivative is 3t squared. And then the 4t, the derivative is 4. Okay, so there's the derivative of f and g separately. We're now supposed to look at this new function. Does my yellow one work? I feel like it didn't work very well. Which is the product of f and g. So we have the 2t squared multiplied by the t cubed plus 4t. We're supposed to distribute the 2t squared in and then find the derivative. So distributing in gives us a 2t to the 5th. When you multiply two things with powers, you should add exponents. And then we get an 8t cubed. And the derivative of that function is first sum and difference. So we'll look at this. The 5 drops down in front. We get 10t to the 4th. And then 8t cubed, so the 8 sits there. The 3 drops down in the front. We get a 24t squared. Okay, so this is the derivative of p. No question here, that's absolutely right. We used rules that we know, so we rewrote it as a sum and then applied all the rules that we have. So the question is, does that equal f prime times g prime? So if we take f prime and we multiply it by g prime, f prime was 4t and g prime was 3t squared plus 4. And if we distribute that in, we get 12t cubed plus 16t, which absolutely does not equal what we got when we took the derivative of p using rules that we know. So the goal here is for you to be really convinced that when you multiply two functions together, the derivative of your new function is not the same as the product of the derivatives of your old function. So basically what we're saying here, this is really important that you know this. This derivative is not f prime times g prime. So the derivative of a product is not the product of the derivatives. And then for the quotient, we are given this function q of t, which is the same as g of t divided by f of t. And we're supposed to, again, take the derivative of q by rewriting it and using the rules we already have. So rewriting it will mean dividing the 2t squared into each term. So we'll get q of t is equal to t cubed over 2t squared, which is going to leave us with the 1/2 t. So we get to cancel out 2 of the t's. We're left with the t in the top and the 2 in the bottom. So you could make it t over 2 as well. And then we'll get a 4 over 2, which is 2. T divided by t squared is leaves a t in the bottom, so that's a t to the -1. And the derivative of that is going to be, it's a sum now, so 1/2 t, the derivative will just be 1/2, and then 2t to the negative 1 will drop the negative 1 down. It'll be negative 2t to the negative 2, which is 1/2 minus 2 over t squared. Okay, so there's our q prime. And again, the question is, would we have gotten the same thing if we took g prime and divided it by f prime? So the question is, if you want the derivative of a quotient, can you just take the derivative of the top and the bottom and make a fraction out of that? Okay, so g prime up at the top, I know you can't see it, was 3t squared plus 4, and f prime was 4t. So when we divide the 4t in, we get a 3/4 and a t cancels, so 3/4 t. And then 4 over 4t, the 4's will cancel, and we'll just have a 1 over t, which again is absolutely not equal to what we got when we rewrote the function and took its derivative using rules that we know work. So here again, I want you to be really clear on the fact that the derivative of a quotient is not equal to the quotient of the derivatives. So you can't just take the derivative of the top and bottom separately. All right, thanks for